In this video, we're going to solve an equation containing two square roots that each have variable expressions inside them. Like simpler equations with variable expressions inside them, inside the square roots, we will isolate the radical and square each side of the equation. This will only eliminate one of the radicals though, so we will need to repeat this process a second time. So let's get started. We're told to solve the equation that has the square root of t minus 7 on the left, and on the right has 3 minus the square root of t. We're then asked to formally check our solution, which we'll do at the very end. So the first thing we want to do is isolate one of the radicals. In general, we isolate the most complicated radical, which in this case is the square root of t minus 7. The square root of t minus 7 is already isolated as it sits on the left-hand side by itself. So as our first step, we will square each side of that equation. We'll square the left side and we'll square the right side. The left side, we have the square root of t minus 7, and it's squared, so it will simplify to t minus 7. On the right side, though, we have 3 minus the square root of t, and that quantity is squared. So we'll simplify it to 3 minus the square root of t times 3 minus the square root of t. The left side will stay t minus 7 for a couple more steps, and now to simplify that right side, we can expand it. We could use a shortcut property, or we could fully FOIL it. So going through, I'll FOIL it. I'll get 3 times 3 is 9. Outside terms, I have 3 times the negative square root of t, so I have minus 3 times the square root of t. For my inside terms, I again have minus 3 times the square root of t. And then for that last term, I have the negative square root of t times the negative square root of t, so I can write that as plus the square root of t squared. To simplify this left side, I have t minus 7, and on the right, I'm going to have 9, and then negative 3 times the square root of t, and negative 3 times the square root of t. Those are like terms, so I'll combine them. And I will have 9 minus 6 times the square root of t when those are combined. That square root of t squared will just simplify to t. So as the last term, I will have plus t. At this point, I have a simpler equation, but I still have a radical inside it. So we're going to take the same approach we had the first time, which is to isolate the radical and then square each side. So the radical that remains is negative 6 times the square root of t. So I'm going to isolate that square root of t and then apply that process of squaring each side again. To do so, I want to simplify each side. So I see that I have terms containing t on each side and constant terms on each side. So my first step, I'll subtract t from each side, and it'll cancel on the left side, so I'll have negative 7 on the left. T minus 7, subtract t, I'm just left with negative 7. On the right, I have 9 minus 6 times the square root of t plus t, so if I subtract t from that, I'll simply have 9 minus 6 times the square root of t. Continuing on, I still want that square root of t all on its own, so I'm going to subtract 9 from each side. And when I do that, I have negative 7 on the left, so negative 7 minus 9 will give me negative 16. And on the right, after I subtract 9, I'll simply have negative 6 times the square root of t. So at this point, I almost have the square root of t on its own. I have negative 6 times the square root of t, so to get the square root of t on its own, I'll divide each side by negative 6. So I have negative 16 over negative 6, and then I'll have negative 6 times the square root of t over negative 6. And so on the left, negative 16 over negative 6 will give me 8/3 when simplified. And on the right, I'll have the square root of t. So at this point, I have the square root of t all on its own. I can now repeat the process of squaring each side to finish solving for t. So on the left, I'm going to have 8/3 squared. And on the right, I'm going to have the square root of t squared. The left side will then simplify. When I square 8/3, I'll get 64 over 9. And the right side, I have the square root of t. When I square that, I will simply get t. So the proposed solution that I have for t is the number 64 over 9. Now when I go to check this, I'll make sure that I check into the original equation. And so I'll take that square root of t minus 7, replace t with 64/9, and on the right side I'll take 3 minus the square root of t and replace that t with 64/9. So coming in, looking at our check, square root of, and here we have 64/9 inside that radical, and we are subtracting 7, and then we're going to check, and on the right we're going to have 3 minus, we'll have the square root, and then inside there we're going to put 64/9. So this will involve a little bit of fraction arithmetic here to simplify this by hand. On the left side, I have 64/9 minus 7 inside that radical. I want to get that into a single fraction, so I'll turn that into the square root of 64/9. And then to make 7 also have a denominator of 9ths, I'll multiply by 9/9. And so I'll be subtracting 63/9. I'm checking then if that's equal to 3 minus the square root of 64/9. That square root of 64/9 can be broken up into the square root of 64 over the square root of 9. And we'll see that 64 and 9 are both perfect squares, so that right side's going to simplify nicely. So continuing on, let's finish with that right side. We had 3 minus the square root of 64 over the square root of 9, so I have 3 minus 8/3. And then looking at the left side, inside that square root we have 64/9 minus 63/9, and that's just 1/9. So we'll have the square root of 1/9 on the left. Simplifying further, we're pretty close here. The left side becomes the square root of 1 over the square root of 9. And the right side, to combine that 3 and negative 8/3, I'll write that 3 as 9/3, giving it the same denominator. So I have 9/3 minus 8/3 on the right. On the left, the square root of 1 over the square root of 9 will simply be 1/3. And on the right, 9/3 minus 8/3 is indeed 1/3. So I've checked that each side has the same value when I plug in 64/9. And so I'll summarize and state that my solution set contains the number 64/9. So I'll write 64/9 inside curly braces.